Okay, so today we are going to look at lesson 8.1. We're talking about the imaginary unit I. So it starts off here with the equation x squared plus 1 equals 0 and telling us that it's a pretty special equation. And at first, a long time ago, the earlier mathematicians thought that this equation had no solutions. So the reason why they thought that they had no solutions is because, first of all, this isn't factorable, right? If that were a minus, it would be a difference of squares, but it's not. So they tried to move the 1 over and said, okay, well, x squared equals -1. And then they said, okay, no solution because there is no real number that I can square that's going to give me a negative result. So that was their thinking, that if x squared equals -1, then the square root of a negative number isn't a real number. So next, the book talks about Cardano, who was kind of the first person to break through with these imaginary units, and it talks about some of the things that he did to get there, which, if you're interested in the history part, is good. The math part of this, I think, is actually a little more confusing than what is needed. So we're actually going to skip, if you want to draw an X through number 2, 3, 4, 5, and 6, we are going to skip down to the bottom of page 122, where we have our definition of the imaginary unit. So Cardano was the first to develop an understanding that imaginary numbers existed and that we can actually solve the equation x squared plus 1 equals 0, but that the solutions are positive and negative square root of -1. Much like early on in math, they developed the symbol pi to represent the irrational number that we sometimes approximate as 3.14. They wanted to come up with a symbol that would represent the square root of -1. So that is what I is. So anytime you see I in math, it is representing the square root of -1. They typically always write the I in like script or Danielian, so most of the time you'll see it written like this with the little tail. But it stands for the square root of -1, and it is one of the solutions of that famous equation. So the first thing that we need to be able to do with imaginary numbers, other than know that I is the square root of -1, is to simplify imaginary numbers when you have something other than a 1 underneath. So it says here, to simplify an imaginary number, the square root of -s, where s itself is positive, so that means the opposite of s is negative, we can write the square root of -s equals I radical s. Now, the reason why this is true actually goes back to what we did with radicals in class. This right here can be written square root of s times square root of -1. And since we know that the square root of -1 is I, that's how they get I radical s. So that's where this comes from. So what we need to be able to do with it then on the next page, top of 123, is to simplify some radicals that have those square roots. Now, on these, if it comes out evenly, I don't need you to show me the work that I just showed on that last page. So you can do this if you want, radical 25 times radical -1, and then write, okay, that's 5, this is I, so that gives me 5i. But it's perfectly fine with me if you just write 5i. Same thing here. The 7 doesn't break down. I know because of the negative I'm going to have an I, so it's going to give me I radical 7. I don't need you to show me the work there. The only ones where I do request that you show work are the ones where you are having to do either factor tree or biggest perfect square method to simplify the actual radical itself. Now, something that's really important is how we write our imaginary numbers. So out to the side, make sure you jot this down. I should be placed after whole numbers, but before radicals. And that's actually like an important thing. That's part of standard form, is writing it the correct way. So 5 is a whole number, so I comes after the 5, just like it would if it were a variable. The radical 7, obviously a radical, so I comes before it. So the order does matter. So here, if I write this like this, and again, you don't have to do this step, but I know that 12 is 4 times 3, and this is 2 times 2, which means that I've got radical negative 1 times 2 radical 3. So here, the I that I get from this square root of negative 1 needs to come after the whole number, so after the 2, but before the radical. So I get 2I radical 3 there on part C. So let's look at one more like that. The negative I know is just going to give me an I. So I know that there's going to be an I in a radical 150. I have to see if 150 can break down. So the biggest perfect square that 150 is divisible by is 25. It's 25 times 6. So when I'm breaking that down, that means that a 5 can come outside. So 5I. The 6 is stuck inside. And I have 5I radical 6. So these are our answers here in the Try These A. All right, what I would like for you to do is to try to simplify 9A and 9B. So you can take a minute to discuss with your group for a minute. I'll just wait here. Go ahead and do 9A and 9B. Okay, so for 9A, because of the negative, I know that that means that there's going to be an I in my answer. The 98 is 49 times 2. So that means the square root of 49 brings a 7 out. The 2 can't come out, so I have 7I radical 2 for A. For part B, I've got that negative outside, so be careful with that. Then for the 27 I know is 9 times 3. 9 is 3 times 3. So I have a 3 that gets to come outside as well as a 3 that's stuck inside. Now be careful with this one. You had a negative on the outside. That needs to be brought along. So negative on the outside. Then my whole number that came out was 3. This gives me my I, and then I still have a radical 3 left because of this 3 that could not go to the matching outfit party. So negative 3I radical 3 for your answer there. All right, so that allows us to simplify the imaginary numbers. So now I need to move on to what we call complex numbers. So on the next page, we've got the definition for that up at the top. A complex number is in the form a plus bi, where a and b are real numbers, and I, of course, is the square root of -1. So a complex number has two parts. The real part is a, and the imaginary part is bi. So here they tell you in the complex number 2 plus 3i, 2 is the real part, 3i is the imaginary part. So if we look at A, 5 would be the real part, 8i would be the imaginary part. On B, 8 would be the real part, 0 would be the imaginary part, because if there is no bi, that means that B was 0. So 0 would be the imaginary part there. Here, similar to in part B, 0 would be my real part. I don't have a part that is not attached to the I. This is my imaginary part. D is a little bit tricky because you have to simplify it first. Make that 5 halves plus 3 halves I. So now it's easy. This is the imaginary part. It's got the I attached. This is the real part. I always get a few people who think that on C, that they just put I as the imaginary and radical 10 as the real. Remember, it's bi. So any number that is attached to the I by multiplication is part of the imaginary part of the complex numbers. All right, next thing is plotting complex numbers in what is called the complex plane. Now, we won't really do more with this, but I do want you to see how to plot these in the complex plane. Sorry, it's hard to scroll just a little bit. I can do this. There we go. So, when we plot in the complex plane, the real axis is your x-axis, the imaginary axis is your y-axis. So they give you some examples here. So A asks you to graph 2 plus 3i and -3 minus 4i on the complex plane. So here my real part is 2, so I go to the right 2 units. My imaginary part is positive 3i, so I go up 3 on the imaginary axis. This guy right here is 2 plus 3i. -3 minus 4i, I would go left 3 on the real axis and down 4 on the imaginary axis. This is -3 minus 4i. So what I would like for you to do, you can consult with your group if you'd like, but go ahead and pause the recording and just plot all the complex numbers from the bottom here. So part B, C, D, E, and F. So pause the recording, take a minute. Once you're done, then unpause it, and we can check your answers. Okay, so to check your answers, part A, 2 plus 5i, you should go right 2 and up 5, so that should be right up here. So if you, or part B actually. So you could either label that B or label it 2 plus 5i, either way. Part C, 4 minus 3i, that means go right 4 and down 3. So here is where you should have 4 minus 3i. D, negative 1 plus 3i, so left 1 and up 3. Negative 1 plus 3i. Then E, negative 2i. Since there is no real part here, that means the real part is 0, so all you do is just go down the 2. So negative 2i is right there. And then F only has a real part, no imaginary part. So you go left 5 units, and that becomes our negative 5. All right. So that is the gist of what we have with the complex numbers. In your homework, which is, I believe, 17 through 22 on page 125, I do want you to be careful with number 22. I don't want you to say, I don't remember it. It's just a formula. So it tells you the sum of two numbers is 8, their product is 80. It wants you to write an equation. Use the quadratic formula. Guys, you have Google at your fingertips. You should know the quadratic formula, but if you do not, then look it up to use it. I will give you one hint on this, that you have to get the equation equal to 0 first before you start using the formula. The rest of these are so quick and easy. They should take like 2 seconds for some of them. So this one you will have to think a little bit. You may have to look up that formula, but do get the equation equal to 0 first. And that's all we've got for today.